Current touch input technologies are best suited for small and flat applications, such as smartphones, tablets, and kiosks. However, these technologies are too expensive to scale to large surfaces, such as walls and furniture, and are incompatible with objects having irregular and complex geometries, such as tools and toys. We present Electrick, a low-cost, touch-sensing technique for large, irregular, and rapidly prototyped objects. Adding touch interactivity to objects is easy. First, we add a conductive coating to an object. Then, we attach sensing electrodes to the periphery of the desired interactive area. An optional top coat can be applied. With this setup, Electrick can detect different touch locations as well as enable coarse, continuous touch tracking. Our sensing principle works by injecting a small electric current into the conductive layer using a pair of electrodes. We then measure the voltage at all other adjacent electrode pairs. When a finger touches the surface, some current is shunted, causing a localized reduction in voltage. To better estimate the touch location, we rotate the current-emitting pair and repeat this process. This results in a mesh of cross-sectional measurements. Using tomographic reconstruction, we can create a 2D touch sensing image, revealing finger locations. Here is a real-world version of our illustrated setup, this time using 16 electrodes. The tomographic output is visualized on the laptop. We can apply standard computer vision blob tracking techniques to capture finger locations and movement. To demonstrate the expressivity and versatility of Electrick, we built a variety of fully functional example applications. First, there are many solid materials that are compatible with our technique and can be used in milling, molding, stamping, and other common manufacturing processes. An example material is Velostat, a carbon-loaded polyolefin film most typically used for packaging of electronic components. Velostat can be attached to flat surfaces with adhesive to make inexpensive touch panels. Or, when laminated to thermoformable sheet, Velostat can be vacuum formed into a variety of 3D shapes, such as a phone case. Now touch sensitive, the case can detect different user grasps, which in turn can launch different applications, such as a camera, or open the keyboard in a messaging app. Electrick can also enhance the functionality of rapidly prototype objects and experiences. For example, a designer can use Electrick to prototype a controller interface, using the same static body, but with different interactive control layouts. Another example material is carbon-loaded ABS, sold as a filament for 3D printing and also as pellets, chiefly for injection molding. 3D printing is a particularly powerful prototyping tool. However, the output is generally static. It embodies the desired 3D form, but rarely the interactivity of the end product. With Electrick, 3D printed artifacts can be made touch sensitive, enabling rapid iteration of both form and function. Second, liquid paint and spray coatings are particularly versatile, allowing Electrick to be applied to existing objects to augment them with touch sensing capabilities. For this, we use carbon conductive paint, primarily used for electrostatic discharge and RF shielding purposes. This can be easily sprayed or painted onto almost any surface, flat or irregular, and at a variety of sizes. For example, we spray painted an electric guitar and attach electrodes along the edge of the instrument, enabling touch tracking. In this demo, a user can add custom controls to the guitar body using a companion laptop application. We use a similar fabrication process on this steering wheel, which can detect the location of both hands, as well as hand gestures. Electrick also scales to large surfaces, such as this desk example. We brush painted this desktop and attached electrodes to the periphery. In this example, stickers can be used to bind table locations to functions on a laptop, allowing for quick access. Touch input on surfaces as large as walls is also possible. We carbon painted a sheet of drywall, which we then covered with standard latex wall paint. In this example light control application, tapping the wall toggles the light. Dragging up or down allows the user to control brightness. Finally, there are also conductive materials that are soft and pliable, which are most often used in molded products. One example is conductive silicone, which we created by mixing carbon fiber and conventional silicone.
Judge me by my size, do you? May the force be with you.
With Electrick, it is also possible to use Jello to create touch-sensitive objects.
The occipital lobe is the visual processing center of the mammalian brain.
Finally, Play-Doh is also compatible with Electrick. In this example, a user can sculpt a figure or object and bind sound effects to different touch locations.
Don't touch my nose. I'm melting.
For more details and example applications, please see our paper.